time to go the other way. We want to now take this equation in rectangular form because it has x's and y's, and we want to put it into polar mode, which means we would have r's and thetas instead. We use those same equivalency thingies that we just had, like for instance x squared plus y squared is r squared, so we can replace that. And then x right here is r cosine theta. This is one possibility for our answer. We can also think about if we were trying to solve this for r so that we could put it in our calculator to graph it, we would want to say, hey, they both terms have an r, so let's factor that out. Basically the opposite of what we did on the previous problem. We want to take the r out and divide both sides by r, which gives us r minus 4 cosine theta equals 0, and then you could add it over like so. This is another possibility, as well as that one would be another possibility of an answer. So as far as where to stop, like stop when you think you're good. Maybe it'll be multiple choice to help you out on knowing where to stop. On 20, we want to find how far apart these two planes are, given what they have in polar coordinates. So if we think about what this looks like, we're all in the first quadrant. Wow, that's pretty bad. Let me try again. We're in the first quadrant. The first airplane is at 11 degrees, which is this way. The other one is at 87, which is this way. And then this one is out 8 miles, so we could say that that's out 8 for fun. And this is out 7. And basically we are trying to find the distance between those two lines, so from here to here. And one thing that is neat about this then is that we know what this angle right here is because we can subtract. This is 11 degrees to get to here. It's 87 to get all the way from 0 over to the green line. So if we subtract 87 minus 11, that gives us the angle between, so that's 76 degrees. To figure out this third side then, we just need to use a little law of cosines, because we have side angle side here. So the law of cosine says the side we want to find squared equals one of the sides we know, one of the sides we know plus squared, plus the other side we know squared, minus 2 times those sides, times cosine of 76. Now, be careful, because this is really easy to type in your calculator, but sometimes we try to be smarter than we have to be and we put it in the calculator wrong. Just put all this in at once. 76 is not on the unit circle, so we don't have to worry about exact values. So just type in, all in one spot, 7 squared plus 8 squared minus 2 times 7 times 8 times cosine 76. By the way, make sure you are in degree mode because it says 76 degrees. Press enter and you should be getting, for x squared, 85.905-ish, and then if you take the square root of both sides, that should give you 9.268 miles. Okay. Now 21 has to really do with graphing this to see what it looks like. So we have this polar equation 3 minus 4 sine 3 theta, and we want to find for what values of theta do maximum r values occur. We can figure out really easily the max r value here is 7, because you always take these two numbers in front, add them together, and you get your max r value. But that doesn't tell us where it happens. And so what we would want to do is we would actually want to pull up a graph in function mode to see at what thetas this is happening. Because if you look at it in polar mode, it can be really hard to tell. Like, is it happening at? Are they happening at 0? Or are they happening at pi? Like, what's going on? So, graph this in function mode on your calculator, and we're looking for where between 0 and 2 pi, because that's what the question asks us. Where between 0 and 2 pi are we hitting those max values of 7? And so there's clearly one at pi over 2, assuming that you have your calculator set to zoom trig so that you can see the little tick marks. There should be one at pi over 2, and there is a max there. There are 2 other places where there are maximums that are much more difficult, if you ask me, to figure out where those are. So what it has to do with, basically, is we get our max R value of 7. How? If we ended up with 3 plus 4, so that this would have this sine 3 theta, it would have to be -1, right? If sine 3 theta equals -1, to solve that we would inverse sine both sides to get 3 theta equals the inverse sine of -1. Then we have to ask ourselves, okay, where all does sine have a value of -1? And so on your unit circle, look for a y value of -1, and that should happen at 3 pi over 2. And so it happens at 3 pi over 2, and then it should happen again 2 pi later. So that would be 3 pi over 2 plus 2 pi, which would be like plus 4 pi. So that's 7 pi over 2. And then where else? And I'm just going to do one more. And that's because if I divide by, there are more, you could keep going indefinitely, but if I divide by 3 on each one of these, then my theta values, if you look, I'm going to get pi over 2, because that divides evenly right there. I'm going to get 7 pi over 6, and then I'm going to get 11 pi over 6. And if we think about where those maxes are happening on our graph, it makes sense that that's where that could be. That 7 pi over 6, it's a little bigger than pi, and 11 pi over 6, well, it's a little short of 2 pi. So if it's not clear from the graph exactly what's going on, you have to sit here and think, what's going to give me a value of 7? I have to have 3 plus 4, but this was a minus sign, right? So I need to figure out when will sine 3 theta be -1. If it had been a plus sign in the middle instead of a minus, we would have set what it was equal to +1 instead, to figure out what the max values, at what values the max R happens. So that one's kind of tricky. So you can do it though.